Okay, so we had talked yesterday about how this was approximately normal for our sampling distribution for p hat because of the large counts condition. And I believe we had ended with number 11, like right at the end of class, but I'm going to leave it here in case anybody needs to get that jotted down into their notes. And then I want you to look down at number 12. Our sampling distribution for p hat is approximately normal. So I can sketch that normal curve. Remember, when we sketch our normal curve, we want to label our mean. We want to show our standard deviation. And then when we do this right here, we're saying that this curve is approximately normal. And once again, we're naming our mean and our standard deviation. One thing that I want to point out here too, looking right here at sigma for p hat, if I have the old sigma, so if I already know the old standard deviation, then I want to find the sample standard deviation. Sigma for p hat is equal to sigma over the square root of n. So if I have a sample from a population and I know what the standard deviation is for that population, that's what we did right here. This was our old standard deviation, and we divided that by our sample. I want to divide by the square root of n when I take a sample and I know the standard deviation of the population. And we'll look at that here a little bit more in a moment, but just go ahead and jot that down into your notes. That's saying if I have this piece right here already, if I know that bags of Reese's Pieces contain exactly 40% that are orange, and we select a random sample of 50 candies, what's the probability that the sample proportion will be 50% or more? What would this look like? Because we said this was approximately normal. Where would I put 50% on here? What'd you say? What's right in the middle? What's my mean? 0.4, so 40%, right? Is 50% going to be to the right or to the left of that? It's going to be to the right of that. So I want to know 50% or greater, so I would put 0.50. I would put this down on number 12. And I want to know everything more than that. So down on number 12, redraw your normal curve. You're going to put 50% on there, and you want everything to the right of it. How would you find that probability? We know two different ways of doing that. How could you find that probability once you draw your normal curve? See who remembers from before break. We can calculate a z-score and look it up on table A. I'd have to do 1 minus what table A says since I want the greater than, and table A only gives me the less than. Or I can pull my calculator out, right? We can do a normal CDF. My lower bound would be 50%. My upper bound would be 100% or 1. And then we have our mean and our standard deviation. Let me pop that up on the screen here. There we go. So there's my picture. I can calculate my z-score, the proportion that I'm looking for, 50% or greater, minus the known proportion, 40%, divided by my standard deviation. I get 1.45. So I look that up on the table. If I look that up on table A, that's 0.9265. But since I want the greater than, I have to do 1 minus that. Or I can put it into my calculator, normal CDF, to get this value right here. Or something approximately that value. Write down our big ideas for today. Has everybody had a chance to see? Yes, ma'am.
I have a question. So is there ever going to be a time that we have to use one over the other?
Where you have to use table A? No, but there will be times where you would have to calculate a z-score by itself.
Okay.
So make sure you know how to calculate the z-score. What this z-score is telling me, 1.45, that tells me that if the mean were 0 and my standard deviations were 1, I would be just a little bit less than 1.5 standard deviations away from that mean. That's what that z-score is telling me. That this value of 0.5 is just a little bit less than 1.5 standard deviations away from that mean of 0.4. Let's write our big ideas down. So top of the next page. 3 big ideas. Mean and standard deviation. My mean for p hat, my sample proportion mean, is just p. My population mean. The standard deviation for p hat is the square root of p times 1 minus p all over n. If the 10% condition is met. If the 10% condition is not met, then I can't look at this. As long as I have not sampled more than 10% of the population. It is approximately normal if my large counts condition is met. And if the sampling distribution is approximately normal, so if my large counts condition is met, we calculate our z-score as p hat minus p, so the value that I'm interested in, minus the true population proportion divided by the standard deviation. I'm going to come around and pass some little baggies out to you that have candies in them. Please do not open them. When you're done copying down the big ideas, I want you to try to check your understanding on your own. Again, once you've copied down the important ideas, I want you to try to check your understanding on your own. So I want you to identify the mean of the sampling distribution. I want you to calculate and interpret the standard deviation. Check that your 10% condition is met. Is the sampling distribution approximately normal? How would you know if the sampling distribution is approximately normal? I want you to find a probability, so that's going to be similar to number 12. And then I want you to look at that challenge question, part E. Whoa, sorry, I took that off this correct page. Let's look at the first couple questions here. Identifying the mean of the sampling distribution. What is the mean of our sampling distribution? 0.08, yes. how would we calculate the standard deviation? Sigma p hat. How do we calculate sigma p hat? Square root of, and then I need a fraction bar, you're right, p, 1 minus p, all over n. And what did we say our p value was? 0.08. So what would 1 minus p be? 0.92. All over what? All over 1,000, yes. Over 1,000. What does that come out to be? 0.0086, so I'm going to round that to 0.009. But you can write 0.0086, that's absolutely correct. Yes. What does that mean? How would I interpret that 0.009 or 0.0086? What does p hat mean again? What'd you say? Not the mean, that's what my mu means. What does the p hat mean? Proportion, but with the hat over it, it means, it is a proportion, but it is a, starts with an S. Sample proportion. So my sample proportion of adults that have never had a cavity, the sample proportion of adults that have never had a cavity, typically varies by how much? 0.009 from the true proportion of 0.08. How would I check that that 10% condition was met? How do I know that my 10% condition was met? Where did we get our sample from? 1,000 adults. Where are those 1,000 adults coming from? It doesn't say. I'm going to have to use some intuitive thinking here, but considering the fact that they're citing the American Dental Association, we're assuming that this simple random sample of 1,000 adults is coming from somewhere in the US, right? What would 10 times 1,000 be? 10,000. Are there at least 10,000 US adults? So if I sample 1,000 adults, have I sampled more than 10% of my adult population? So my 10% condition is met. Sometimes we have to use a little bit of intuitive thinking here. I'm going to take my sample, I'm going to multiply it by 10, and then I'm going to make the argument that I know there's more than 10,000 adults in the US here. Is this approximately normal? Yes. How do I check that? Large counts condition, so n times p, n times 1 minus p. There we go. So we have our sampling distribution mean. We have our sampling distribution standard deviation. We have the interpretation of it. We checked our 10% condition. There's more than 10,000 adults in the US, therefore the 10% condition is met. All I did was take this inequality right here, and I multiplied both sides by 10. And then checking my large counts condition, n times p, so 1,000 times 0.08, which is 80, that's more than 10. N times 1 minus p, so 1,000 times 0.92, 920, again, bigger than 10. Even if it comes out to be exactly 10, my large counts condition is met. It just can't be less than 10. So yes, it is approximately normal. still up on the screen. I'm going to scoot onto the next screen. C will still be up there. A and B are going to scroll off the page. You guys okay with that? Find the probability that the random sample of 1,000 adults will give a result within 2 percentage points of the true value. Within 2 percentage points of the true value. Where'd it go? There it is. Is this approximately normal? Yes. So I'm going to draw my normal curve. What do I want right in the center? 0.08. 8%. Within 2 percentage points. So 8%, and then I want 2% on either side of that. So what's 2% smaller? 0.06. What's 2% bigger? 0.1. So I want this in here. What have I forgotten on my picture? Standard deviation and one other thing. I need that n. I need n showing me that it is approximately normal, 0.08. And what did we say our standard deviation was? 0.009. Two ways you could go about doing this. What are those 2 ways? Yes. We would have to calculate 2 z-scores, one for this one and one for that one, and then we'd have to subtract them after we found them on table A. Or I can do what? Normal CDF. Then I put in my lower bound. What was our lower bound? 0.06. Then my upper bound, 0.1. And then if you're using a TI calculator, what comes next? Mean. If you're using a Casio, yours is switched around. Your mean and standard deviation is switched around. Mean next, so 0.08, and then your standard deviation, 0.009. And you pop that all into the calculator there. Lower bound, upper bound, mean, and standard deviation. So it turns out if you calculate the z-scores, what we find is that 0.06, it's a little bit more than 2 standard deviations to the left of our mean. That's what a z-score is telling me there. There's my final value, Grayson. I wasn't sure if you saw that.
I got 0.
It just gave you straight up 0? Yeah. Let me come and look at that with you in a moment. It might have to do with how it's floating. Shouldn't, but it might. And then because I'm interested in us moving on, go ahead and copy down the answer to part E, but I'm not going to take the time to go through that right at this moment. You got it? Did you do PDF instead of CDF?
No, I put it in the maximum thing.
But it turned out different?
Yeah.
Okay. Yeah, when I did it on my calculator, I'm within 1/10,000th, so I'm only off by 1 decimal place from using table A. If the sample size were 9,000 rather than 1,000, the distribution is going to remain approximately normal. The mean stays the same. If my sample size changes, my mean stays the same. Because remember, my sampling distribution mean of p hat, is just p. The size of my sample does not affect that at all. It does affect the standard deviation though. Standard deviation would decrease to 1/3 of the value. As my sample size increases, my standard deviation gets smaller. When my sample size gets bigger, my standard deviation gets smaller. Yes, ma'am?
What is that after the 1 0? Is that a multiplication?
Oh, right here?
Yeah.
Yeah, it's just a multiplication symbol. All right. Let's go down to something a little bit more fun. The candies in the baggies. Don't open up the baggies. You don't want to eat these. We're going to use these in another class period later. Plus, my kids who helped me separate these into baggies, I cannot swear as to how clean their hands were. So it's easier if you leave them in the baggies. You don't have to worry about kid germs. What we're going to do now is I want you in each of these baggies. One holds Skittles, one holds M&Ms. Each baggie has 50 candies in it. So 50 M&Ms, 50 Skittles. We want to count the number of orange in each baggie, and then we're going to do the proportion. So it's out of 50, out of 50. Count the number of orange in each. And we're going to write this down then on page 11 in your packet. Confused now. There we go. Okay. So you want to count the oranges in each of these. You're going to record the proportion of orange M&Ms, the proportion of orange Skittles. And remember, it's out of 50, so your denominators on both of these are going to be out of 50. There we go. Skittles first, apparently. Check my count. And then count the proportion for the orange M&Ms. Pop those into your calculator so that you have a decimal as well. this right here. That's p hat 1. That came from my first sample, my Skittles. M&M's, that's sample proportion, is p hat 2. And then I want you to find the difference of those. We're going to do Skittles minus M&M's. So for mine, I'm doing 0.2 minus 0.34. So I get a negative 0.14. This guy right here, that is p hat 1 minus p hat 2. Once you have that value, you're going to come up here and put it on a dot plot. So I'm going to put negative 0.14 up for mine, and then you guys can come and add your dots as well. So here's my first. Once you have your difference between the sample proportions, come and add your dot. I'm going to turn around and help everybody. So just label it over here on the side. It's not falling on the So it's just like a check mark over it. Just pop it on there and label it. I'm sorry, I'm right in the way. Go ahead and copy the dot plot into your notes as well. I'm going to send around a bowl. Just put the M&Ms in this bowl. So you should still have one bag in front of you. Just put the M&Ms in the bowl. Keep these separated. That's okay, no worries. It's hard to keep them separated. Oh, I just tripped over somebody's bag. I don't knock it over. Sorry. M&Ms. Oh, thank you.
I can't tell what's going.
So I'm just curious, I realize this dot plot is a little bit messy, but what are you noticing about it? They're all on the negative side. Like, we didn't have any that were positive. How did we set this up when we did our subtraction? Skittles minus M&Ms. What do you think that means about the sample that I got when I went to the store and I bought these Skittles and these M&Ms?
The Skittles have less orange.
Skittles have less orange, like by far, at least in the sample that I got. each dot represents? Yes, sir. Yes. Thank you. Yes. Does everybody have the basic dot plot jotted down in their notes? Okay. It's all skewed off to the left. The difference in the proportion of orange candies for one sample of Skittles and one sample of M&Ms. It's the difference in proportions. I'll pop this back up on the screen in just 1 second. I did want to add one thing to our dot plot, and that was just a label up at the top. This is the sampling distribution p hat 1 minus p hat 2. So each one of these dots is p hat 1 minus p hat 2. What did our shape look like for our dot plot? Even though I know it was really far over on the left side, what was the approximate shape? Anybody want to hedge a guess? What about if we'd done this 30 more times? What shape would it be approximating at that point? As my sample sizes go up, as I take more and more samples, my sampling distribution is going to become more and more what shape? Approximately normal. As I take more and more and more samples, my sampling distribution shape will always take on a more and more normal shape. I realize that ours looked a little wonky, but this is approximately normal. Let's go back and look and see if we can figure out where the center was. Ballpark. Where does the center appear to be? Yeah, somewhere between like negative 0.16, negative 0.14, somewhere in there. Let's go with negative 0.16, because that's the first one that I heard. Our variability, our standard deviation, let's go back and look at that. If this truly had an approximately normal curve, what would I be looking at? Does anybody remember from first semester? One standard deviation on either side grabs about how much?
68%.
About 68%. So if I go in just one direction, that'd be about 34%, or about a third of the dots, right? So if I wanted to go about a third of the way over, looks like if we're right here, there's about 3 dots there, 4, 5, 6, 7, 8, 9, 10, 11. So our standard deviation is probably here-ish. How far over would that be? 0.04. Again, we're just kind of ballparking and looking at this. 0.04. If it's approximately normal and I want to estimate that standard deviation, I want to look for about 34% on one side of the mean. All right, go ahead and flip your page over. So Google search, I'm going to argue with Google on this one, or at least with the M&M's factory, unless they've changed it. Google search revealed that Skittles, the Skittles Corporation, claims that 21.6% of their Skittles are orange. M&M's says that it's exactly 20%. So according to my Google search, where should we have seen more orange? I should have seen more in the Skittles, right? We should have had some positive ones. Do we have any positive ones at all? Nope. We're going to pick up here with this page first thing tomorrow. Remember, homework assignment. Technically, I said it was due tomorrow. Let's push it one more day. Let's push it to Friday. I'll change the due date in Canvas. So homework, you get one extra day on, due on Friday. Have a great one, everybody.